to work on making a assembly. This is Dave, the unemployed inventor guy. I guess you always have to be cautious of getting information from a guy's unemployed. Well, I'm a genius in my own mind. So I'm going to use a part that we didn't do together. I'm going to put that in as the base part. Now what we need to do is to lock it into place, and the best way that we're going to be able to do that is by using Planar Geometry. So we're going to take this plane and constrain it to that plane. Let me change our edges. Do you see how the back solid part, I want to have the open part on this side, so you just change the direction. So we got that. Now we want to do this plane. So the only plane we don't have now is the XY plane. So I'm going to take that one. And I don't want to go to the inside of the part, I want to go onto the other side. So if you remember the technique, just kind of go over it and we'll get it. I want to go the opposite way that it's going right now. There we go. So now we've got the back piece going against that plane. So now we have a part that's in place. What we could do now is we can add another part into it, and this will be the part that we worked on together. Now, the first part that we want to do is we want to now use, again, Planar Geometry to locate these two pieces together. Take that plane and constrain it to this plane. Again, it had the same problem, went the wrong way. So, if we look from the side, we can go up and forward with the part, but it's centered this way, so it can only go up and forward. So our next course of action is going to be the XY plane, or XZ plane, sorry. So we're going to constrain, and again it went the opposite way. Apply. So now we have it all constrained except for front and back. And now on this one I'm not going to constrain to planes. This is I'm going to constrain this flange, the outside of this flange, and I want to go to the inside of this flange. So I'm going to hover over it, apply. So now we have a part that's completely grounded, actually is the term that they use. This part would have been the grounded one, it's not moving, and then this one has been constrained to that one. One of the reasons for using the Planar Geometry was I had made the inside part a 32nd smaller than the outside part, so there's actually a gap here, and the way you can check that, and it got found all by using the Planar Geometry. We have 17 thousandths there, 17 thousandths there. If we come over and check these other two sides, $17 thousandths there, 17 thousandths there. So see, it found itself very nicely by using the Planar Geometry. So we want to save this assembly. We're going to be assembly 6. And now I'm going to make a drawing. You have to save things to make a drawing. So remember last time when we made the flat? Well, this doesn't have a flat, obviously. So we're going to make it a little bit smaller, though. 1 to 5. Drop it in there. And now we can actually project these views. This one, again, is a little bit big. So first thing I want to do is I want to do that little kind of dark shaded area, kind of like that. And we'll make this a little bit bigger. And, you know, I'll tell you something about those ISOs is you don't really have to use them all the time. You should just use them whenever you need them. If we go inside here, since this was the main part we put down, we can change this and we can put the dotted lines, and all the dotted lines come up here. You can see where our little space is for the insulation or wiring or whatever we're going to do to it. The other part that we can do here too, it's really cool, is we could use the sectional view. Come on in here and you click in the area where you want to do it. Do continue. Come over here. And so now we have a sectional view. And for some reason it puts a scale on there. I always found the scale was kind of useless. I don't know, who cares what scale it is. If you care about scale, good. I didn't really need it. So now I'm going to put a few dimensions. One of the things now about the dimensions is, since it's a top level, you might want to just put fractions. Probably not going to have welders using calipers to do this. We don't need to see that anymore. Then we can put another dimension over here. One of the other cool things that you're offered with Inventor, which I don't know if it's unique to it, SolidWorks probably has the same application, is you can take a parts list. So we're going to take a parts list for here. Okay. So we have the bottom cover and the top cover. The bottom and the top cover. And you can also now balloon those parts, so you can say which ones are which is kind of cool, especially if you have a lot of parts. And again, here when we were looking at our cutaway view, you can see the 17 thousandths gap there, how they come together. Here's our half-inch flange, there's a half-inch flange. Again, you can dimension as much as you want. Again, we see over here the title is not there. As I've told you before, I like to do it in the assembly. I like to use the description in the assembly, but if you remember, this is looking for the, if we do have a definition, you'll see that it's looking for it in the properties of the drawing. If you remember last time I changed it to the model. So, but let's, for this exercise, let's go in and make it so that there's I-properties for not only the models but for the drawings. So it was title, so we'll call it assembly. I like caps. Assembly, apply, and we got our name. So we save it, and I got a nice drawing. Okay, see you next time.